Exercise 3D looks at combining the transformations, so dilations, reflections and translations. Now, if you're not given any kind of order, so the question says that it undergoes a dilation or a transformation such as blah blah blah, then you assume an order of DRT, so Dr. T, dilations, reflections, translations. That is unless you're told otherwise. So for example, if the question says that it does something followed by something followed by something, then there's an assumed order, so you would go with that order. This does change the equation, so if you're looking to find an equation or to graph something or to move something, the order of these transformations actually does matter, so please be careful. We're going to look at two examples on this. So the first example is to find the equation of an image when the graph of y equals root x, so square root function, is translated 6 units in the negative direction of the x-axis, reflected in the y-axis, and dilated by a factor of 2 from the x-axis. Because this is stating that the graph is or has had this happen, followed by this happen, followed by this happen, there's actually an assumed order to this question. So instead of sorting the transformations into the order of DRT, we'd actually state that that's actually not needed for this question. So not needed, as there's an assumed order already there. Alright, which means we go straight to step 2. So step 2 is that flowchart with the transformations. So that this 6 units negative direction of the x-axis is x minus 6, common y, because y is not shifting. A reflection in the y-axis means that our x value becomes negative, and then a dilation factor of 2 from the x-axis, so the y value is multiplied, means 2y. So that's our flowchart of the transformations in the correct order. We then take our new x and our new y and make it equal to our transformed x and y. Then solving for x, and then solving for y. Remember, this is what we're going to substitute into our original formula of y equals root x. So instead of y, we write 1/2 y new equals root 6 minus x new. That's a direct substitution from up here. So x equals 6 minus x new, and y equals 1/2 y new. That's where that's come from. And remember, we never write an equation with something with the y, we do rearrange it. So multiplying both sides by 2 to give y new equals to 2 root 6 minus x new. That's our end answer. So we put a red box around it, and that is done. Alright, so this example, so example 2, is for the graph of y equals x squared, quadratic, and we have to sketch it after it undergoes a sequence of transformations. So we're going to sketch each graph separately. So we're going to do a translation 1 unit positive direction of the x-axis, so 1 right, and then 2 up. A dilation factor of 2 from the y-axis, which is kind of stretching it across wide, so making it wider basically, and a reflection in the x-axis, so flipping it across the x-axis. Alright, that first one. To graph this, so a normal graph would be y equals x squared. So this graph here would be our normal graph, and we're actually going to move our, I suppose, our turning point, or any point, we're going to move it across 1 and up 2. So our turning point is now going to be at 1, 2. And the shape from that hasn't changed. So we still have some key points. For instance, 0, 3 is across 1 unit, up 1 unit, just like negative 1, 1 is 1 and up 1. The same deal goes for 2, 3, it's across 1 and up 1. So I haven't changed the shape, I've just moved where it is. So the black graph is after the first transformation. I then take this graph, so this is my graph that I just did have, and we're now looking at a dilation. So a dilation factor of 2 from the y-axis means I'm going to take each of these points and multiply them, the x value, by 2. So the point which was at 1, 2 is now going to be at 2, 2. I had a point at 0, 3. 0 times 2 is 0, so that's still there. And I did have a point that was at 2, 3, and 2 times 2 is 4. The 3 value won't change, so that's here now. So this is going to become my new graph. It's just wider, but we technically haven't shifted it horizontally or vertically. We've just dilated it. It might be worth chucking in some key points so you can follow those points. Okay, the last transformation that we need to look at is our reflection. So this is our old graph, and then we're going to reflect it in the x-axis, which means any point that I had up here is now going to get reflected down. So if it was at 2, 2, then it's now at 2, negative 2. If it was at 0, 3, it's now at 0, negative 3. And if it was at 4, 3, it's now at 4, negative 3. And then just drawing that in, and we get ourselves our final graph, which is this one here, putting in some coordinate points for scale, and then that's done. The second part, part B, says state the rule of the image. So the image is your equation, basically. So after changing y equals x squared using these transformations, what's actually the rule for the image of that? All right. So we're going to do this using our coordinate point, x, y, which then undergoes the transformations or translations. So we're going to +1 and +2. We're then going to dilate, and then we'll reflect. So those are our 3 transformations we undergo: our translation, our dilation, and our reflection. That gives us our new x and our new y, which we can then put into an equation. So new x is equal to 2 bracket x plus y, and new y is equal to negative y plus 2. Brackets are important, keep those brackets. Rearranging it to get what x equals, and then also rearranging it to get what y equals. This is what we substitute into our original equation of y equals x squared. So instead of y, we write negative y new minus 2, and instead of x, we're going to write 1/2 x new minus 1 squared. Now we're going to play with this a little bit because it's not quite nice. I don't like this half in here. We can't have a negative and a negative 2 here, so we're going to do some algebra. You might want to pause along the way and have a look, but I'll try to talk you through it. First step, get rid of the negative 2. So I'm going to +2 onto both sides. Get rid of the negative, so multiply everything by negative 2, making sure, by negative 1, sorry, making sure that this 2 on the end is also multiplied. So I have a negative here, and that goes to a negative there. The next step is that I'm going to pull that 1/2 out. I've just made a mistake. There should be no negative and negative 2 there. But pull that 1/2 out the front here. So when I do that, instead of having negative 1 like I've got here, I'm going to have 2, because 2 times 1/2 is negative 1, or negative 2 times 1/2 is negative 1. Pulled that out the front there, which removes it from here, which means that I can actually square it, so 1 squared and 2 squared, so 1/4, and remove it from this bracket totally. It's just nicer, and as far as dilations go, we're a bit more clear with it being out the front here. I then can keep going, and then it's a rearrangement. Now this is going to give out the correct answer. So that is my correct answer. This step in here, or these 2 steps in here, I've kind of done them twice. I actually took this equation here from here. So please don't fret about that. The end answer here is correct, but you don't need this part in here. So put a box around that and you are done.